Day 1. A small but powerful tremor is shaking the city of Naples, Italy. The news networks are reporting on the event. The experts believe that Mount Vesuvius, the stratovolcano on the Gulf of Naples, will explode soon. But when? It's erupted many times in the past. In fact, that's how it got its shape. It's made of multiple layers of hardened lava, pumice, and ash. Vesuvius last erupted in 1944, but a major blast happened there nearly 2,000 years ago. It buried the Roman towns of Pompeii and Herculaneum and decimated the surrounding areas. Today, 3 million people live less than 20 miles from the volcano, and 600,000 live in the danger zone. Large eruptions happen every few thousand years, usually after long periods of calm. And the trouble is, Vesuvius is long overdue for its next one. This time, though, the volcano is being watched by the Vesuvius Observatory. It has seismic stations, special GPS arrays, and satellite-based radar to help it measure ground movement. They also have special equipment to test the chemicals found in the gases coming from the volcano. All of this helps the experts work out whether it's about to go off. But will it? Right now, the magma is more than 6 miles from the surface. Things seemed safe yesterday, but now they're about to take a turn for the worse. Day 3. Another tremor comes in measuring 3 on the Richter scale. All the equipment that's installed near the volcano is now going off. The magma is pushing upwards. It's not at the surface yet, but Vesuvius is definitely restless. 2 more tremors follow in the afternoon. They don't feel like regular earthquakes, and geologists can see the difference in their seismographs. Volcanic quakes register about 4 to 5 less on the Richter scale. Now, the experts are sure it's just a matter of days or weeks until the volcano erupts. Some volcanoes can be restless for months or even years before they go off. But that's not how it goes with Vesuvius. Day 4. The ground starts to crack open, as if a giant creature is trapped in the Earth's crust and is trying to desperately get out for some air. Steam escapes from the little cracks in the soil. Certain areas are hotter than others. If you went there, it would feel like you walked straight into an oven, and it would be hard to breathe. Some sheep got too close to the mountain and passed out. When the farmer found them, he almost collapsed too, not from the heat, but from the gases. Carbon dioxide and hydrogen sulfide are being released into the air. The entire area around the volcano smells like rotten eggs, and many of the forest animals are now staying clear. The nearby trees have been absorbing these gases from the soil for days on end now, and they're starting to turn brown. The carbon dioxide levels in the area are skyrocketing, and all the detectors are beeping constantly. Day 6. The tremors are getting more frequent. Experts at the Vesuvius Observatory monitoring the volcano say the quakes are coming from the magma that's being pushed upwards. A few hours later, the national emergency alert goes out. Thousands of local people have around 15 days before the volcano erupts, and they need to evacuate their homes. The 600,000 people in the danger zone start to pack their suitcases and leave in cars and trucks. There's chaos everywhere. But in all that disorder, some people are standing still. They look around, trying to understand what's really going on. A few of them are taking photos of their homes. Others are streaming all the confusion on social media. But the senior citizens are just standing outside, looking at their houses one last time. They hope this is all just a false alarm. It's happened before, but who really knows? Day 7. It was a sleepless night. Plenty of the locals have already left. Some good people from other towns drive to the area to help the residents evacuate faster. There's a massive traffic jam, but everyone expected it. This is why the evacuation started early. Ferries, trains, and buses have canceled their services to help the evacuees. They're all working on a tight schedule to make sure everyone gets out safe without any delays. Some people refuse to leave, but their neighbors eventually convince them to go. It will take 7 days to evacuate everyone, and these people will spread out to other areas of the country, not just to the nearby safe regions. Day 10. More than half of the residents have now left the red zone. After the chaos, there's now silence, and it's interrupted by the eerie sounds of the tremors. Animals are being evacuated too. Many people are now trying to save as many animals from the forest as they can find. Day 16. All 25 of the towns that were at risk have now been evacuated. The red zone is empty. But the tremors are getting stronger, as the volcano is a pressure cooker ready to explode. White smoke rises from the large opening on the mountaintop and the vents on the side. The molten rock moves toward the surface, and the pressurized gases form bubbles, just like the ones you see when you boil food. Suddenly, there are some loud booms, and then an explosion. It's loud enough to be heard thousands of miles away, and the shockwave is felt throughout Italy. Volcanic rock is thrown up into the air. A thick black mushroom cloud forms and expands into the sky. The birds abandon their nests and fly away in huge flocks. The red-hot lava is now spewing out of the volcano like a fountain. As it flows downward, it obliterates everything in its path. Then there's a volcanic landslide. Part of the cone-shaped mountain falls off, and millions of tons of soil and rock break loose from the volcano's side and tumble down. The lava spreads on the slopes, and it slowly slides down into the forest and the farmlands. The plume of ash, pumice, and other kinds of rock has risen so high into the sky that people can see it from Rome. Then the tower of debris starts falling back to Earth. First comes the ash, then chunks of rock. The ash in the atmosphere is so dense that it's hard to breathe. The lava slowly spreads across the area and pulls down all the trees. All the nearby towns are shrouded in darkness and smoke. Buildings collapse, and all around there's a mixture of heated, poisonous gas and rock moving faster than a car. Other rocks and more volcanic ash fall miles away from the volcano, hitting cars and destroying roofs. The sky is completely black as the lava keeps on coming. Slowly, all the nearby towns are submerged beneath the molten rock. Some of the lava even reaches the sea. Gigantic white steam covers the shore where it falls in, and the magma turns black. Now, a weird neon blue fire appears on the slopes of Vesuvius. This is caused by burning sulfuric gases. They're escaping at high pressure from the cracks in the volcano surface. When they come into contact with the air, they ignite. These blue flames can reach 16 feet into the air. Now, all nearby flights are canceled, and many planes have to change course to reach their destination. Ever since the national alert, no planes have been allowed to fly over the volcano. The clouds of volcanic ash can damage jet engines and other plane components. The water supply is now contaminated by streams of volcanic ash, and it smells unbelievably bad. In just a short amount of time, all that magma has made entire towns vanish. Only the roofs of taller buildings can be seen. After the big and explosive eruption, there are some smaller and quieter ones. At this stage, nobody knows if the volcano has stopped erupting yet, and absolutely no one can go anywhere near the area. 10 years later. Most parts of the red zone are now hidden under hardened but still warm lava, including the ancient site of Pompeii. Some people have started to forget about what happened. Others have begun their new lives elsewhere, and some don't even want to think about what happened to their old homes. But several of them are counting the days until they can go back. 100 years later. You're walking in what appears to be a wasteland of volcanic ash. You suddenly realize that you're standing on top of your great-grandparents' town. Everything is now submerged under a thick carpet of solidified lava. But below it all, just about everything is still intact, completely frozen in time. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? they tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha! Loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm. Or at least, we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area, but the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60 but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts.
It happened around 8.7 million years ago. All of a sudden, vast grasslands started to open. Clouds of volcanic gas and ash covered the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. It was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on the planet, wasn't named Supervolcano for nothing. Spreading deep underground and extending for hundreds of miles, supervolcanoes are complicated structures. Experts are still unsure what processes can trigger these fire-breathing monsters and lead to super eruptions. When it happens, more than 240 cubic miles of ash, molten rock, and hot gases get hurled up into the air. 4 super eruptions would be enough to fill the Grand Canyon to the brim. Volcanoes create mountains, but supervolcanoes wipe them off the face of the Earth. They change climates and ecosystems. Thankfully, these disastrous events don't happen more often than every 50,000 years or so. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground and burst through the Earth's surface. Usually, all this magma gets stuck, unable to break through the planet's crust. Large pools of pressurized bubbling magma gather at a depth of several miles. The pressure keeps growing since more and more magma is trying to get to the surface. And then, wham, bam, a super eruption goes off. All those millions of years ago, the first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust, leaving behind huge chambers Those were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding after more and more magma arrived with time. The land over the volcanic system was inching upward, slowly, almost unnoticeably. A year before the super eruption, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle with soda after you've shaken it. Something like that was happening near the volcano. The pressure was released through the fractures when gases were bursting out from under the surface. Right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurtled up into the air to a height of over 16 miles. Within several minutes, a pyroclastic flow rushed across the area at a phenomenal hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With the temperature of more than 1,300 degrees Fahrenheit, it was burning everything in its path. The volcano kept pumping ash for days on end. The air in that area heated up to 570 degrees Fahrenheit. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds after being inhaled and getting in the lungs. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a 10-feet layer of ash covered the territory of about 50 miles around the center of the eruption. In the end, tiny particles of volcanic ash coated almost all the western part of North America. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. The monsoon seasons changed. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It covered more than 8,900 square miles of what's now southern Idaho and northern Nevada. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. There have been at least 3 other supereruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 64,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent supereruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. These days, Yellowstone National Park is a mind-boggling collection of 10,000 mud pots, hot springs, geysers, and vents emitting volcanic gases. Heat-loving microorganisms live in most of them. They paint the park in its brilliant colors. The most famous geyser is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than others, erupting about 17 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach the height of 180 feet. Scientists have spent many years trying to figure out what's hiding under Yellowstone Park. They've discovered that surface water goes several miles down into the crust. It gets heated and boils, supplying the geysers. Around 7 miles below the surface, there's a reservoir of half-melted rock. That's the magma chamber, and it's more than 30 miles wide. An enormous plume of hot rock, which looks somewhat like a mushroom, feeds this chamber. It rises from the depth of 400 miles, traveling through the planet's upper mantle, a thick layer of mostly solid rock. Sometimes, this plume overheats the magma chamber. The land in that place lifts, and tiny earthquakes help some liquid escape to the surface. The pressure inside the chamber drops, and the ground lowers again. Since 2004, some parts of the Yellowstone caldera, which is a clever word for a volcanic crater, have been surging upward much faster than usual. The rate's been almost 3 inches per year. No uplift has been that quick since scientists started close observations in the 1970s. And still, experts are sure the supervolcano doesn't present any danger these days. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even if there's some volcanic activity, it's more likely to be a spurt of oozing molten rock, known as a lava flow. It does present some danger, but it's easily avoidable. Or it can be a hydrothermal explosion. Then, a large volume of superheated water trapped below the surface will rapidly turn from liquid into steam. This steam, along with boiling water, mud, and pieces of rock, will burst through the surface with great force. Then, the debris will litter the area of up to several miles in diameter.
So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud pots, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface, and the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1,800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea. But sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be, and the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight. It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital, molten rock suddenly burst through the surface from below, leaping soundly. We divide volcanoes into 3 categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943. It started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal Volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mudflow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yusur in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ale is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down.
In 79 CE, the Vesuvius volcano erupted and burned down 2 beautiful cities of the Roman Empire, Pompeii and Herculaneum. Many of you have probably heard about this tragic story. However, few people know that in the middle of the 18th century, archaeologists discovered ancient scrolls from that time amongst the ruins of Herculaneum. For any scientist or historian, such a discovery is a treasure trove that offers insights into the thoughts and lives of people from over 2,000 years ago. However, the problem was that 1,800 scrolls were found in very poor condition, singed by the heat of the volcano, coated in ash and soot. They had become hardened black lumps. Brittle as coal, any careless movement could destroy them. Scientists were aware that invaluable knowledge from an ancient Roman library was concealed within, and endeavored to decipher the texts. One method was to cut the scrolls in half and scrape off the thin layers of solid dust and ashes. Then, the researchers created a special machine that could slowly unroll the scrolls. They managed to read a few words, but unfortunately, such methods damaged and even destroyed some of the artifacts. In those instances, archaeologists could only wait for advancements in technology that would allow them to unfold and read the scrolls. And finally, this day has arrived. Artificial intelligence has now enabled researchers to decipher texts written 2,000 years ago, even though the inscriptions on the scrolls were charred and nearly illegible. Initially, scientists scanned the scrolls and created high-resolution digital models. This process allowed specialists to identify the areas where ancient ink had altered the texture and shape of the papyrus fibers. In the regions where ink was applied, the papyrus was slightly thicker and contained a higher level of carbon, the key component of the ink. The researchers developed a machine learning model capable of detecting these subtle details within the papyrus. They uploaded thousands of 3D images of the scrolls to the internet, inviting people to collaborate with AI in decoding the text. During the early stages, the system occasionally made errors, making human assistance essential. To incentivize participation, scientists and investors from Silicon Valley offered $1 million to anyone who could successfully decode the texts. This initiative significantly accelerated the process, resulting in the deciphering of several passages from the ancient works. Fragments of the first transcripts are like a blog about how to enjoy life. The author of the scroll, Philodemus, was a follower of the Greek philosopher Epicurus, who considered pleasure and luxury the highest goal in his life. So, Philodemus thought so too. We do not right away believe things that are scarce to be absolutely more pleasant than those which are abundant. It feels as if it was written by some modern influencer talking about a detox program or a diet. It seems that people who lived 2,000 years ago were almost the same as modern ones. Philodemus was apparently a wealthy man, because he lived in a villa that may have belonged to Julius Caesar's father-in-law. In his works, the author criticized the Stoics, who couldn't say anything about pleasure at all. Philodemus was such an ardent fan of Epicureanism that one of the scientists compared him to a guy who collected albums from only one band and nothing else. Several hundred Herculaneum scrolls remain unread. Scientists believe that they may contain works by Aristotle, Homer, Sophocles, and the Stoics. Fortunately, with modern AI technologies, the decryption process will go on much faster. But how did historians and linguists decipher ancient texts in the past centuries? It was actually a very difficult mental job. Let's say you found an ancient slab in the 19th century somewhere in Greece. To understand what was written there, you'd have to compare it to several other deciphered plates with similar writings of that era or similar languages. Letter by letter, symbol by symbol, you'd be deciphering ancient writings for several months or even years to figure out, say, the recipe for ancient mashed potatoes. Fortunately, with the development of computer technology, those days are long gone. Now, all ancient scrolls can be scanned and uploaded to a database on a computer. You may not even have to decipher the text for a long time if the computer finds a match of characters in other ancient manuscripts. But even if you have a perfectly preserved piece of papyrus or an ancient book where all letters are visible, this doesn't mean that you and AI will be able to decipher it. One of the most famous encrypted texts is the Voinich manuscript. This work, which consists of 240 colorful pages, was acquired by Polish bookseller in 1912. He found that book intriguing because of astrological symbols, unknown plants, and unusual human figures drawn on its pages. And all this was accompanied by handwritten texts. The author had beautiful, clear handwriting, but the language of the book is still unknown. Someone wrote this art book around the beginning of the 15th century and divided it into 6 sections devoted to botany, astronomy, biology, cooking, medicine, and cosmology. Many scientists and linguists have tried to decipher the mysterious drawings with inscriptions, but no one has gotten reliable results. Even AI couldn't help this difficult task. Some believe that this book is dedicated to science, and others believe that it contains knowledge about witchcraft. Perhaps it's a mix of science and magic. According to one version, the manuscript is a medical textbook that copied information from other scientific works from the Middle Ages. Before the invention of the printing press, people copied books and rewrote them by hand without worrying about copyrights. It's possible that the author of the manuscript outlined all their knowledge about herbal medicines and the influence of astrology on health. People in the past believed that the state of the body and stars in the sky were connected. The coolest thing is that the book has been scanned. You can download it in high resolution and try to decrypt it yourself. Who knows? Maybe you will succeed and get some ancient secret knowledge. An unknown language or poor text condition may not always be a problem for linguists. Imagine that you open some copy of classical literature dated to the 19th century. You read the pages carefully, and at the end of the day, you feel slightly unwell. You read the book every day and feel worse and worse. At some point, you go to the hospital, and doctors tell you that you've been poisoned. Yeah, sometimes working with old books can be literally dangerous for your health. There are even catalogs of poisonous books in the world. They are toxic not because someone intentionally sprayed them with poison to hurt the reader, but because people wanted to make books look more colorful. Recently, 2 such books have been withdrawn from the National Library of France because of their bright green covers. The pages were ordinary, but the hardcover could have been coated with arsenic. The mass production of books took place in the 19th century. Book publishers wanted to release as many copies as possible, so they used not expensive leather covers for them, but cheaper fabric options. To make a book attractive to customers, they painted them in bright green, yellow, red, and other colors. They got the green color of the cover thanks to the bright pigment created from copper and arsenic. It was a very cheap dye, but brighter than other dyes containing copper carbonate. An arsenic dye was used not only for books, but also to create candles and wallpaper. The problem was that the dye's pigment decomposed quickly and released toxic carcinogenic fumes. Arsenic caused severe health problems. People calmly lived in their homes and couldn't understand what was happening to them. The same thing happened to many readers of that time. It was only by the end of the 19th century that people stopped selling toxic items. Now, to read a poisonous book, if you want to do it that is, you have to wear gloves and a protective mask. And after work, wash your hands thoroughly.
When you think of a volcano, what's the first thing that comes to mind? Streams of red, steaming hot lava pouring over the sides? Dark clouds of ash rising high into the sky? Maybe you think of a relaxing hot spring. Ah, that's nice. Well, we all imagine one thing, a cone-shaped mountain looming over the horizon. But it can be as green and lush as any other mountain. At the top, of course, there's a giant hole, like an opening that goes all the way down. Inside, there's lava and gases being pushed outside. Lava is so hot that if you were standing at the top of the volcano and looked down, your face would feel as red as the color of that liquid rock oozing out. A volcanic eruption never comes without consequences for us. And I'm not just talking about people living nearby. The impacts are usually felt on a global scale, too. Can't fly for a while because of the blanket of ash released in the air. Not to mention, it might be a bit tricky to breathe. Carbon dioxide, sulfur dioxide, and plenty of other toxic gases whose names immediately take you back to your high school chemistry class. Funny enough, most of that cloud rising out of a volcano is just water. Well, vaporized from those scalding temperatures. But before any volcano erupts, it goes through stages like an angsty teen. First, magma, that's lava before it erupts onto the surface and gets its name change, starts moving underneath the volcano. This causes earthquakes that get worse and more dangerous over time. Then, steam and different gases start spewing out of holes in the planet's crust. Our Earth resembles a tea kettle about to whistle. When the gas emissions and earthquakes get more massive, it usually means the volcano is about to blow its top. But those first stages can take years before an eruption happens. Then, the magma starts building up. With more and more pressure, it's planning to make its great escape. It's hard to notice this happening if you don't have the proper equipment. Good things scientists do, and they've got us covered. The volcano becomes more active by the minute. Ash starts coming out and spreading in the air, creating ominous clouds that turn day to night. With the magma building up, an eruption is imminent. Then, boom! The surface gives in under the pressure below. The magma makes its exit. It's now lava, spewing out the top and flowing down the sides of the mountain. None of this sounds very appealing. So, what if it never happened? What if there were never any volcanoes at all? Would Earth still be the same? Not at all. If volcanoes never existed, there wouldn't be an atmosphere. When our planet was still just a young pup, volcanic gases are what created our protective bubble that allows you and me to breathe right now. They also played a big part in shaping the land and oceans. 4 billion years ago, Earth was still forming. It didn't look anything like the pale blue dot we know today. It was red hot, and the water was trapped under the crust. It wasn't until the surface started to cool down and solidify that the water was finally able to escape. Volcanoes acted sort of like a tear in the fabric of our planet. Water vapor would condense in the atmosphere and then fall back down as rain. It rained for so long that the third planet from the sun started turning into the blue ball we're more familiar with. In fact, there's even a theory that all the water on Earth came from volcanoes. And without water, of course, life wouldn't have been able to form. Land formation went through a similar process. You see, our planet was a pretty rough place to be when it was forming. It was a molten surface with fields of lava and constant volcanic eruptions and space rocks always crashing into it, because there was no atmosphere to protect it. When it started cooling down, a good solid surface formed, but the hot material underneath was still boiling and bubbling, and it continued making its way up. The crust would move and form thick layers with the material that was rising up. Over time, these layers became more permanent. Volcanic eruptions were still happening, but the first landmass had finally formed. Okay, we'll take the best part of volcanoes, an atmosphere. So what if they stopped erupting long after we got our protective breathable shield? Still not good. For starters, volcanoes created the most fertile soil. Around Naples, you have the famous Mount Vesuvius. The soil quality there is incredibly rich, and that's thanks to two huge volcanic eruptions, one that happened 35,000 years ago and another 12,000 years ago. Sure, these volcanoes caused a lot of short-term damage, but in the long run, these soils were fertilized by them. Now the region grows all kinds of citrus fruits, olives, grapes, cherries, and of course, their staple, tomatoes. There'd be none of that without rich volcanic soil, and Naples is by far not the only example like this. Bacteria, the first living organisms, lived in hot water. Scientists have discovered fossilized microorganisms older than 4 billion years. They thrived in hydrothermal vents. Those are fissures on the sea floor, and they're usually near volcanically active places. This means that without volcanoes, we wouldn't have land, water, or even the first life forms that, as the theory goes, would eventually evolve into all the creatures we have today. Could life have still developed on Earth without these explosive mountains? Doubtful. Okay, fair enough. We want our atmosphere and life. So let's say volcanoes stopped erupting today, after we already have all these benefits. Well, we're sort of already there, based on this story. At the start, there was only one continent, Pangaea. It was a supercontinent surrounded by one massive continuous superocean. Volcanic activity by this time had finally calmed down, and this meant all that energy would gather below the Earth's crust. Here's a little diagram. First, we have the Earth's inner core. Then there's the outer core. Next up, we have our convection currents. Magma is next in line. After that, the oceanic crust. And at the very top, we have our ocean and our continental crust. The reason Pangaea eventually broke up into the separate continents we have today is because of plate tectonics. It's not like the crust is all one solid piece. It's broken up into big chunks, or plates, that are always moving. And it's all still moving today. Yes, the land you're standing on right now is sort of surfing on that layer of convection currents. It's a slow process, so it's not like you can feel it. Pangaea didn't break apart all at once. It took tens of millions of years. When the plates move, they cause earthquakes and volcanic activity. They create mountains too. It's good for our planet as well, because the Earth gets to sort of renew its old crust. If there was no volcanic activity now, the pressure underneath the Earth's crust would keep building up. It'd get to a boiling point the continents couldn't handle anymore, and eventually, they'd start splitting into more numerous and smaller masses. Volcanoes are still useful to us till this day. For one, they cool our atmosphere. Their eruptions release sulfur gas. It combines with water in our atmosphere and cools it at its lowest level, which is where we live and breathe. There's also an excellent use for their heat. Geothermal power plants harness the energy coming from deep inside the Earth and turn its heat into steam. We then use that steam and turn it into electricity. This is the case for our friends in New Zealand and Iceland, since they live in places with high underground temperatures. Volcanic material can also be made into blocks for building stuff. It can be grounded down to make cement, too. If we want, we can even search volcanoes for precious minerals like gold, copper, and sulfur. And who can forget about hot springs? Tourism to places like Yellowstone and Iceland wouldn't be the same without them. And who doesn't love a nice steamy dip in the ones safe for swimming? Oh yeah. In the end, volcanoes aren't so bad after all. Our beautiful Earth wouldn't be what it is without them.
If you've ever been to Yellowstone National Park, you were probably mesmerized by its geysers, which spew superheated water and steam high into the air. But an even more intriguing thing actually hides underground. I'm talking about that underfoot plumbing system that makes those grand eruptions possible. About that, there's good news. Recently, researchers have succeeded in mapping the national park's hydrothermal plumbing system with the help of a giant flying magnet. As a result, scientists have managed to document all these features in stunning detail. The thing is, Yellowstone houses the world's largest hydrothermal system. It contains over 10,000 features, like geysers, mud pots, hot springs, and steam vents. They're fed by a network of underground water pathways. Those get overheated by magma flowing underground. It causes the water to rise to the surface. Now, no one actually knows much about the workings of this system, but the newly created maps might finally shed light on it. Experts explain that their knowledge of Yellowstone has a subsurface gap. That's why it's often called a mystery sandwich. Scientists know quite a lot about the features on the surface because they can observe them directly. And they know what's going on in the magmatic and tectonic system several miles below the surface. But they haven't figured out what's happening in the middle yet. So, I must tell you about that giant flying magnet used for research. It's known as SkyTem. It was attached to a helicopter and flown over Yellowstone several hundred times, scanning the ground below. The magnet is made up of an 82-foot-wide charged wire loop. Its main task is to generate a strong electromagnetic field. And since different kinds of material, like water or rock, respond to this field differently, scientists managed to create a few subsurface maps for the first time ever. The mapping technique also allowed the researchers to differentiate between magma and bedrock, since they have a bit different magnetic properties. And the team got a chance to see how the magma and water interact and create those mind-blowing geological features on the surface. The team got high-resolution maps to a depth of around 500 and 2,300 feet, and low-resolution maps showing what's going on at a depth of up to 1.5 miles. At the same time, the researchers think that the hydrothermal system itself may stretch as far as 3 miles below the surface. If they're right, it means they've only mapped the top half of Yellowstone's plumbing system. Anyway, remember how I said that scientists know pretty much about the bottom part of the Yellowstone sandwich? They have such a good idea about the tectonic plates and deep fault lines because the park's frequent earthquakes provide them with a lot of opportunities to study different phenomena. In July 2021, for example, more than 1,000 earthquakes rocked the area. These days, the team of researchers knows much more about some famous features, like the Old Faithful Geyser or the Grand Prismatic Spring. They've also found out that individual hydrothermal features on the surface can actually be connected to others, which can be as far as 6 miles away from them. Another interesting discovery is that even though Yellowstone geysers and hot springs vary in size, shape, color, volatility, and chemical composition, they are mostly fed by very similar underground sources. That means that the difference between the features appears closer to the surface. Now, I'm sure you've seen the iconic image of Yellowstone with a large rainbow-colored spring, fiery orange at its edges. So what makes these hot springs so colorful? Surprisingly, these awesome hues come from microscopic creatures. The temperatures in the springs are so high, they can easily and quickly cook you. Plus, the water there is super acidic, like the liquid in a car battery. But there are certain types of heat-loving microbes that don't mind these crazy conditions. You can even say they're thriving there. So every ring of a different color is, in most cases, a ring inhabited by different bacteria. And each species is adapted to a particular temperature or pH level, which measures how acidic this or that environment is. For example, take the Grand Prismatic Spring, yes, the iconic one. Its rainbow hues likely hint at the diversity of microbes living there. So, starting from the center of the hot spring, you can see a beautiful aquamarine color there. That's where the water temperature is the highest, reaching 189 degrees Fahrenheit, because this area is right over the underground water source. The water there is too hot even for microbes. That's why what you see is mostly clear water. As for the reason for its blue color, it's the same as why the sky is blue. Sunlight hits the surface of the water and the light scatters, but the blue light scatters the most, getting reflected back to your eyes. Now, the next ring of color is yellow, all thanks to certain cyanobacteria. The temperature in this yellow ring reaches 165 degrees Fahrenheit. If the conditions in the hot spring were a bit different, these bacteria would create a blue-green hue, thanks to a green pigment called chlorophyll. But since the sunlight hitting the spring is too intense, the bacteria start producing another type of pigment. It's called carotenoids. And guess what? It acts as a sunscreen for the bacteria. And since this pigment is orange, the normally green bacteria get a yellowish hue. And finally, we've got that bright orange color closer to the edges of the prismatic spring. It's a bit cooler there, around 149 degrees Fahrenheit. In this part of the spring, you can find several types of bacteria. They all produce substances that give the spring this bright orange color. And finally, right at the edges of the spring, the temperature is cooler, around 131 degrees, and a greater variety of microbes can survive there. All of them combined give the edges of the spring that red-brown hue. But scientists believe that people and their activity may have influenced the colors of Yellowstone's hydrothermal features. For example, in the past, the temperatures in the Morning Glory Pool used to be much higher than they are today. That's why its color was a deep blue. But trash has started to accumulate in the pool, and some of it clogged the vent. This caused the temperatures to drop, which led to microbial growth. As a result, that pretty blue color turned into orange-yellow. As for Yellowstone's geysers, the most famous one is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than the others, erupting about 20 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach a height of 180 feet. Now, while talking about Yellowstone National Park, we can't but mention Yellowstone Supervolcano, right? Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. You don't necessarily want to be around for that. Over the past 50 years, the Yellowstone caldera has risen almost 3 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. There have been at least 3 other super eruptions in the history of Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago, long before video. The most recent super eruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spilling out 240 cubic miles of rock, dust, and volcanic ash. No thanks, I'll pass. Huaijan Volcano in Indonesia is not your ordinary lava-belching mountain. Instead of producing black smoke and red lava, as most volcanoes do, this eccentric guy lets out a blue flame and electric blue lava. This phenomenon occurs because the volcano contains some of the highest levels of sulfur in the world, and when the sulfuric gases interact with scorching air and get lit by the molten lava, they start to turn blue. Unfortunately, you can see this mesmerizing sight only at night, but you can smell it all day long. By the way, the world's largest acid lake is also located inside this crater. The Dead Sea has a high concentration of salt and minerals compared to other seas, even though it's technically a lake. Swimming is almost impossible, but people go there for the natural chemicals for the body. Floating on the surface is a great way to relax. This ancient body of water got its name because no macroscopic organisms can live there since it's 9.6 times saltier than oceans. Only a few bacteria and fungi can be found enjoying the salt. It's also Earth's lowest elevation on land at 1,400 feet below sea level. An underground crystal cave exists in Mexico, and it looks like some interstellar world. It's roughly 1,000 feet beneath the surface, with each spike measuring up to 35 feet in length and weighing up to 55 tons. These are some of the largest crystals in the world. Luscantire Beach is an endless strand of white sand dunes and azure water. But don't let the tropical vibes fool you. It's located in Scotland. That's why it mostly looks like this during May and June only. In December, the place gets only an average of 1 hour of sunshine per day, making it way more dramatic and monochrome. The Georgia Guidestones is a collection of giant stones in a star pattern. It has inscriptions in 8 languages, including Hindi, Chinese, and Swahili. It also has an astronomical calendar finished in 1980 and was built to last centuries. No one knows who built it or why. All the way over in sunny California is Sequoia National Park, home to the giant forest. It's been around for thousands of years. More than 8,000 of these colossal trees rule the land, including 10 of the largest living plants in the world. The General Sherman sequoia is estimated to be up to 2,700 years old and is recognized as the world's largest known living tree by volume. The famous stone heads of Easter Island have been around for hundreds of years. No one knows exactly why they were built. Some scientists think that local people believe the statues would make the soil more fertile. Soil analysis proved the heads did their job well. It's the best agricultural spot on the island. The chemical composition of the ancient hot springs in Pamukkale, Turkey, makes the water pouring over the edge look magical. They're not only good for cleansing your body, but the mind too. All the way in Saudi Arabia is a rock sliced perfectly in the middle with 2 pieces sitting parallel. What makes Al Nasla so unique is that it wasn't artificially done, but is a result of nature's work over the years. Now, this glacier may look like someone dropped tons of red paint in the middle of Antarctica, but it's actually the natural color. Blood Falls is a result of extreme salted water mixed with iron oxide, giving out this eerie vibe in the middle of nowhere. In early May 2018, New England observed one of the scariest and most dangerous phenomena ever, a super long-track tornado. The frightening natural phenomenon started not far from Charleston, New Hampshire, and traveled toward the town of Webster in Merrimack County. It took the tornado 33 minutes to cover 36 miles and become the 3rd on the list of the longest track tornadoes in New England. In the Philippines, you can swim in some of the most crystal-clear waters and discover an underwater world below you in the province of Palawan. The municipality of Coron has white sandy beaches with many small boats riding through the many amazing sceneries. Tristan da Cunha is a small volcanic archipelago in the Atlantic, with the only neighboring cities of Buenos Aires, Argentina, and Cape Town, South Africa. It takes 7 days by ship to get to this unique place. If you want to escape from the rest of the world, staying with the 280 locals will make you feel like you're away from everything. During the first week of January 2018, unusually cold weather in the northeast United States froze the Atlantic Ocean in North Falmouth, Massachusetts. What's more, the ocean was frozen so thoroughly that people were walking on the waves. Now, that's obviously something you don't see every day. Red sand is what makes this beach unique and why tourists flock to Tianjin, China. A red-colored plant called a sueda salsa dwells in the saltwater. The whole beach is covered in red, with only the top layer of the sea visible. If there ever was a thing that said, "I defy gravity" out loud, it's the stone of Davasco in Argentina. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately today, you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people of the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. They made a plastic replica of the rock and put it on the same spot and even in the same position. So, even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Socotra is an alien-like island off the coast of Yemen in the Indian Ocean with one of the most unique trees ever seen. It's called the dragon tree, and it can only be found on this amazing island. In 2008, it was labeled as a World Heritage Site. If you ever see a tight burning column of air, don't panic, it's not the end of the world. The creepy combination of whirlwind sounds and scorching inferno means that you have crossed paths with a fire tornado, also known as fire twister or fire whirl. This dangerous phenomenon occurs mostly during wildfires. These fires create a big area of super hot air just above the ground. When this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenadoes can stretch hundreds of feet into the air. The House of Mystery in Gold Hill, Oregon, amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. There's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in the shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoid approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place, and spread the news about it in newspapers and later on the internet, and voila! A perfect anomaly is made. In fact, it's no more than a curiosity, a human-made optical illusion that tricks your eyes and other senses. Now, if you travel to the Philippines, Indonesia, or Papua New Guinea, you'll have a chance to see some of the most unusual and cheerful trees in the world. The trunk of the rainbow eucalyptus looks as if it had been painted orange, green, red, purple, yellow, brown, blue, hey, you name it. Some trees are so bright that they seem artificial. The rainbow eucalyptus regularly sheds strips of bark, which reveals a bright green layer underneath. A bit later, this green layer gradually changes its color, and since the shedding happens at a different time in different places on the trunk, the tree starts to look multicolored and very attractive. Yemen is home to the oldest skyscrapers in the world and the oldest metropolis. The ancient city of Shabam is considered to be the Manhattan of the desert, due to the collection of mud buildings popping out of the desert floor. It used to be a caravan stop during ancient times.
At this very moment, scientists are getting ready to explore the Earth's deepest layers, where temperatures are insanely high and the pressure is crushing. It might sound like a plot from Journey to the Center of the Earth, but it's for real. By 2026, the Krafla Magma Testbed project plans to drill into an active volcano in Iceland. Their goal is to search for magma. Yep, that boiling molten rock that we often associate with destruction. It is a high-risk mission and a huge technical challenge, but the payoff can transform our future. This isn't our first attempt to journey to the center of the Earth. Back in 1959, Hawaii witnessed a breathtaking spectacle as red-hot lava violently erupted from 400-foot Kilauea Iki crater. Over the next 5 weeks, lava fountains erupted in 17 major bursts, with the tallest reaching a record 1,900 feet. This spectacular and terrifying event left behind a glowing lava lake in the crater. A few months after the eruption, the lava began cooling and forming crusts. That was a perfect chance for scientists to drill into that lake, see what was going on beneath it, and collect data about the magma reservoir. Over the next 2 decades, they kept coming back, digging a little deeper each time. By 1979, they managed to get 173 feet down. Up to that point, it was the closest we had ever come to an actual magma chamber. And by that, I mean the underground pool where magma sits before eventually rising to the surface and causing a volcanic eruption. Decades later, the dream of reaching magma finally became a reality. We are now in Iceland in the year 2009. The Iceland Deep Drilling Project has just kicked off. Their goal is to transform the Earth's inner heat into clean energy for everyday needs, such as heating homes and supplying hot water for baths. You see, using heat from the Earth's interior to make energy isn't new, but it usually comes from hot water underground, not directly from a freaking scorching magma chamber. That's why the Iceland Deep Drilling Project was such a big deal. Magma could be a clean, renewable power source. And since it's hotter than the geothermal energy we normally use, it could generate a lot more power. Iceland is a natural choice for this kind of project. Known as the land of fire and ice, this country is home to some of the most active volcanoes on the planet. One of the most popular ones is Krafla, a volcanic caldera of about 6 miles in diameter, located north of the island. So, the initial plan of the Iceland Deep Drilling Project was to go there and excavate 13,000 feet deep. But something unexpected happened. When they were only 6,900 feet down, the drill hit magma. Wow! On one hand, it was exciting, because, well, we finally found it. And just like that, Krafla became the first place in the world where we know exactly where magma is. But on the other hand, their equipment wasn't prepared or built for it, and the molten rock basically corroded their infrastructure, bringing the project to an end. Instead of being a failure, this accidental discovery gave us a ton of valuable data. We realized that, with the right equipment, drilling in such extreme heat is definitely possible. Scientists found that these underground molten pools can in fact produce a significant amount of geothermal energy. And most importantly, we learned exactly where the magma was. That brings us to the current Krafla Magma Testbed project. This scientific program aims to create the world's first magma center. The idea is to set up a base where scientists can safely work with magma and have all the necessary infrastructure to run experiments on volcanic risks and geothermal energy. So that's like the basic idea. But their real plan is to return to Krafla, drill back into it, and create a gateway to the magma chamber. The goal is to understand its potential for generating energy, study its properties, and see if we can use it safely and efficiently. If they pull this off, it could provide a nearly endless source of geothermal energy for Iceland's homes and buildings. Even though magma is incredibly hot, reaching over 2,000 degrees Fahrenheit, experts say it is safe to take energy from it and believe the process won't trigger another volcanic eruption in the country. They're so sure about this, partly thanks to the Iceland Deep Drilling Project. But this whole process isn't like drilling for oil or gas. It's way more challenging and risky. Magma is not just extremely hot, it's molten rock, which can wreck equipment and pose serious safety issues. Right now, the Krafla Magma Testbed project is in its early stages. Scientists and engineers are working hard to develop the tech needed to drill into magma safely. They're testing new drilling techniques, creating heat-resistant materials, and running simulations to figure out what happens when you actually drill into a magma chamber. They hope that by 2026, they will be ready for the next step, which means going back to Krafla and drilling all the way down towards the magma chamber. It might take 2 months to reach it. Their plan is to drill a single hole that will go right into the magma body and hopefully keep the equipment running there for many years. If they succeed, scientists also plan to add special sensors down there to measure and monitor pressure. This could help predict eruptions better and prevent disasters, like what happened with Mount St. Helens in the United States. In 1980, this volcano erupted, causing massive destruction and claiming over 50 lives. The eruption was so intense that it completely blacked out sunlight in Spokane, Washington, which is about 250 miles away. While that sounds terrifying, it's nothing compared to a super eruption, like the one that happened over 70,000 years ago at Toba Volcano in Indonesia. This disaster was about 1,000 times more powerful than Mount St. Helens. Toba is just one of the 20 supervolcanoes on Earth. A supervolcano is what people call a volcano that can produce an eruption of magnitude 8. These eruptions, known as super eruptions, are the largest and most explosive ones. They could have global consequences by affecting the climate and causing widespread destruction. For example, if Yellowstone had a super eruption today, the surrounding states of Wyoming, Idaho, and Montana would be directly affected. They could be hit by hot avalanches of volcanic ash, gases, and rocks that might reach temperatures of up to 932 degrees Fahrenheit and speeds of over 180 miles per hour. This nightmarish scenario is a real possibility, but predicting when it might happen is almost impossible. Volcanoes don't follow a precise schedule, so it is hard to predict when a supervolcano will erupt next. That is also why the Krafla magma testbed is so crucial. By examining a volcano's activity from within, scientists could potentially predict eruptions with much more accuracy. As you might have guessed, drilling into magma is definitely uncharted territory, but the potential benefits are huge. Besides providing a clean energy source and making people who live near volcanoes feel safer, this project might also help us learn more about what is beyond Earth. Yep, it could lead us to breakthroughs in space exploration, helping us understand how other rocky planets and moons formed their crust, just like Jupiter's moon Io, which is the most volcanically active world in our solar system. In the end, the Krafla Magma Testbed project is more than just an experiment. It is a bold vision for the future of energy. It's about pushing the boundaries of science and engineering, taking risks, and dreaming big. So we should definitely keep an eye on Krafla, because this adventure into the fiery depths of our planet could end up changing our future. The last time this volcano erupted was about 500 years ago, but recently, small tremors have grown really frequent, to such an extent that scientists have been recording more than 1,000 a month. I'm talking about the Campi Flegrei supervolcano in Italy. At one point, just a few weeks ago, the area was rattled by a 4.4 magnitude earthquake with 150 tremors in just one night. It was the strongest earthquake in over 40 years. A lot of locals spent the night in their cars, but in the morning, the shakes were followed by another earthquake, a bit weaker with a magnitude of 3.6. So, is Italy in danger? Well, the quake itself wasn't big enough to cause serious damage, but it evoked a lot of panic. At the moment, local authorities are working on grandiose emergency plans. If worse comes to worse, they'll have to evacuate hundreds of thousands of people. One of the reasons is the proximity of this area to Naples with more than 3 million inhabitants. At the moment, they're even considering an option of paying people to leave their homes. Right now, schools remain closed in the Campi Flegrei area. The authorities are allocating more than 500 million euros to ensure the safety of buildings and constructions in the area. A yellow alert is still in place in the region where 80,000 people live. There's the so-called red zone, which is the most dangerous area. There are 1,250 houses in this red zone, and all of them will be at high seismic risk if an eruption begins. Plus, more than twice as many will be at medium risk. Italy is a country prone to seismic activity, and Pozzuoli is a densely populated area that is located on one of the most dangerous supervolcanoes in Europe. Campi Flegrei has 24 hidden underground craters and dwarfs the better-known Vesuvius. Yes, the very volcano that wiped the ancient Roman city of Pompeii off the face of the earth in 79 CE. This city thrived near the base of Mount Vesuvius at the Bay of Naples. In the time of the early Roman Empire, 20,000 people lived in Pompeii. They were merchants, manufacturers, farmers, and others. The soil in the region was rich and fertile, so there were lots of orchards and vineyards. Strangely, no one knew that this black earth was the legacy of an earlier eruption of Mount Vesuvius. The area was a favorite summer destination for rich Romans. Sadly, at noon on August 24, 79 CE, all this prosperity came to an end. The peak of Mount Vesuvius exploded, sending a 10-mile-high mushroom cloud of ash and pumice into the stratosphere. For the next 12 hours, the eruption was wreaking havoc on the city. Volcanic ash and a hail of pumice stones, some of which were 3 inches in diameter, showered Pompeii. It forced the city's occupants to flee in terror. Around 2,000 people holed up in stone structures and cellars, paralyzed by fear. They hoped to wait out the eruption. Who knows? Maybe if they had decided to leave the city immediately after the beginning of the eruption, they would have had some chances to survive. A westerly wind protected the city from the first stages of the eruption. But soon, a giant cloud of hot ash and gas rushed down the western slope of Vesuvius. It engulfed the city, burning everything in its way. This disastrous cloud was followed by a flood of volcanic mud and rock, which completely buried the city. As if the volcano was making sure no one would survive, a cloud of toxic gas poured onto the city, finishing the lives of a few survivors on August 25th. A flow of rock and ash followed. It collapsed roofs and walls and turned the city into a giant cemetery. When a supervolcano erupts, the consequences are usually catastrophic. Supervolcanoes have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually located over hotspots and appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The most recent super eruption happened in New Zealand. Well, when I say recent, I meant around 26,500 years ago. That's when a supervolcano beneath the surface of Lake Taupo spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up into the air at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taupo volcano didn't simply go off like many others. At first, everything was going as usual. Tons and tons of pressurized magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first portion of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground. Thousands of tons of lava, rocks, and ash flew high into the atmosphere. The unusual pattern of Taupo still confuses scientists. The Indonesian eruption at Toba Caldera 75,000 years ago was the largest eruption in the last 2 million years. Experts estimate that the eruption could have released hundreds of thousands of tons of sulfuric acid, which might have even caused a several-degree cooling of the planet's surface. But nowadays, the impact is hard to detect because of glaciers that covered the ground afterward. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced any super eruptions. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperatures made the volcano blow up with a deafening boom. It was clearly heard 3,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. It only had a volcanic explosivity index of 6. Then, there's also Mauna Loa. It's a shield volcano, which means it won't produce explosive eruptions, but its sheer size makes this monster of a volcano extremely dangerous. At the moment, the volcano seems to be at peace with its surroundings. Research equipment doesn't show any signs of activity on Mauna Loa, but if Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places like Captain Cook very fast, in a matter of hours. The last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where the University of Hawaii is located. Luckily, people had a few weeks' warning to get ready for the disaster. Over its recorded history, Mauna Loa has been erupting pretty regularly, almost every 6 years. On the bright side, big island volcanoes including Mauna Loa aren't really very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes are formed by very fluid lava. It travels way farther and forms much thinner flows than the lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So, if Mauna Loa erupts, there probably won't be ash clouds or tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast.
The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now, find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big, it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000-some-foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide, very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear! And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rocks strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. the further the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes, but it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet. So this huge volcano, everyone thought to be extinct, woke up and spat out a black ash cloud 50 miles high. That's about 9 times as tall as Mount Everest. Located in what is now Indonesia, the powerful Krakatoa had caused huge tsunamis that rocked over ships as far away as South Africa. It also changed the temperatures around the world for several years. The volcanic island of Krakatoa in the Sunda Strait was likely born thanks to another major eruption several centuries ago. It hadn't erupted for at least 200 years before 1883. So the first tremors and blasts in May of that year came as a total shock to people living nearby. Then ships sailing through the busy water passage started reporting clouds of ash above the volcano. It went quiet again for a while, but they could still see ash above it. The eruption culminated at the end of August. It was so powerful that it shattered the island into fragments. Witnesses heard the sound produced by it in Australia, around 3,000 miles away. They described the noise as the roar of heavy cannons. Some say it was the loudest sound ever heard. During the next 5 days, the pressure wave from the eruption traveled around the globe 3.5 times and was seen on barographs on different continents. Hot avalanches of ash spread down the volcano as far as 25 miles away at crazy speeds. They ruined the surrounding islands and took 36,000 lives. Tens of thousands more drowned in tsunamis that happened after the volcano had collapsed into the caldera. Over 100 coastal villages on Java and Sumatra were completely wiped out. All this made the waking up of Krakatoa one of the most devastating in the entire recorded history. The Earth's crust is like a giant puzzle, made up of massive pieces known as tectonic plates. These plates are constantly sliding against each other over the mantle, which is the molten layer beneath. Indonesia is right in the middle of the so-called subduction zone. Here, the Indo-Australian plate collides with part of the Asian plate as it moves northward. As the oceanic plate dives down, it gets heated up, and you've got the perfect recipe for a volcanic hotspot. Krakatoa had 3 peaks, each serving as an exit door for a massive magma chamber beneath it. During a previous eruption, debris blocked one of these exits, and the pressure built up beneath. When Krakatoa finally blew its top, the blast split the magma chamber wide open. The eruption led to a so-called volcanic winter. Krakatoa had sent 6 cubic miles of rock, ash, and debris into the atmosphere. They created a thick veil that surrounded the Earth. The particles scattered sunlight, and the troposphere below cooled down. The effect stayed strong for several years. The northern hemisphere experienced colder than average temperatures, and in some regions, summer temperatures didn't rise to typical levels. Southern California received a record amount of rainfall in the months following the eruption. The sky became darker in different parts of the world for years afterwards. The sunsets, for many months, turned into a spectacular show of red and orange. One astronomer supposed it was the source of the inspiration for The Scream by Edvard Munch. The painting shows exactly what the sky over Norway looked like after the eruption. It also produced a rare type of halo called Bishop's Ring and a volcanic purple light at night. For several years after Krakatoa had blown up, the moon looked blue and sometimes green. That's because some ash clouds were full of particles large enough to scatter red light, only letting other colors pass. Someone even witnessed lavender sun and night-shining clouds. Krakatoa became the first scientifically well-recorded and studied eruption of a volcano. Between the moments the first clouds of ash were seen by a ship passing by and the disastrous eruption, scientists managed to organize geological expeditions. They studied the volcano and gathered samples of volcanic rocks. It became useful for understanding volcanic activity. Krakatoa was sleeping tight until the 1920s, when some locals noticed a column of steam and debris spewing from the collapsed caldera. Within weeks, the rim of a new cone sprang up above sea level. After a year, it was a small island named Child of Krakatoa. It continues to erupt, but fortunately without serious consequences so far. In April of 1815, Mount Tambora unleashed a massive eruption, wreaking havoc on the Indonesian island of Sumbawa. It destroyed homes and claimed 10,000 lives. Another 80,000 perished because of diseases that spread in the aftermath. The following went in history as the year without a summer. Cold, wet conditions wrapped Europe and North America in an unexpected chill. It became the coldest in at least 250 years. In the summer of that year, the temperatures dropped the most. Crops didn't grow, livestock didn't survive, and famine took over Western Europe and North America. New England had snow and terrible frost in the summer months. Food prices went up. Oats for horses became a luxury. Some people say it even inspired the invention of the bicycle in 1817. Scientists used early data and climate models to see if it was all because of the Tambora eruption. They compared the data to similar years. They showed that precipitation was around the same, but the temperatures were much warmer. When they introduced the volcano into the scenario, they got the exact data for the year without summer. They say that a powerful volcanic eruption like that one increases the likelihood of extreme cold by up to 100 times. The explosion of the Toba supervolcano on the island of Sumatra around 74,000 years ago became the Earth's largest volcanic eruption in 28 million years. Parts of Indonesia, India, and a slice of the Indian Ocean got a cozy blanket made up of 6 inches of volcanic debris. It spat out a volume of rock comparable to almost 3 million Empire State Buildings. The crater it had left behind is still seen from space. All the ash and volcanic gases that sprang into the atmosphere because of the eruption partially blocked the sunlight. A severe volcanic winter began and lasted for 6 to 10 years. Some anthropologists see a connection between the Toba eruption and how limited modern humans are when it comes to genetic variety. Around 74,000 years ago, exactly when the Toba erupted, there was a population nosedive. That's why all modern humans trace their roots back to a tiny group of survivors. The Toba catastrophe theory proposes that most early humans in Europe and Asia didn't make it through the post-eruption climate chaos. Instead, a lucky, genetically limited bunch found their safe haven in Africa. But archaeological and paleoclimate records disagree with this theory. Benjamin Black from Rutgers University and his team set out to crack the code and discovered a hidden paradox. Maybe we were peering through the wrong climate lens. They ran 42 different climate model simulations, varying the magnitude of volcanic emissions, time of year of the eruption, background climate state, and eruption column height to see what climate disruptions the Toba eruption might have caused. There was a significant drop in temperatures in the northern hemisphere in the first year after the event, up to 18 degrees Fahrenheit. The southern hemisphere, where the early humans were settling, didn't go through a rough cooling that could have affected them all. The most significant eruptions that can seriously change the world's climatic patterns come from supervolcanoes like Yellowstone or Mount Toba. Luckily, these erupt very rarely, about every 100,000 years or more. Still, climate scientists study volcanic eruptions to understand and explain short periods of cooling in the history of our planet. Every few decades or so, a volcanic eruption lets out a substantial number of particles and gases. Some of them will block enough sunlight to start a brief global cooling period. Nothing like the real volcanic winter, but still felt across the globe.
One of the few places you haven't traveled to yet is a volcano. It's an opening in the Earth's crust through which hot gases, molten rock, and other stuff get to the surface of the planet. But which one should you choose? There are different kinds of them. For example, shield volcanoes are built almost entirely of solidified lava flows, or lava domes formed by small masses of lava that are too thick to travel great distances. You can also pick a cinder cone. It's the simplest kind of volcano out there. It's built from blobs of almost solid lava that erupts from a single vent. This lava is ejected into the air with great force. Then it breaks into tiny fragments that become solid and fall back as cinders. With time, they form an oval or circular cone around the vent. Such cones rarely rise more than 1,000 feet. But what if you choose something even more impressive? How about traveling down a stratovolcano? Huge, steep-sided, and powerful. Once you've made your choice, you also decide to opt for an active volcano that is erupting at this very moment. What you're observing now is called a glowing avalanche. The volcano has just erupted a huge portion of lava, which has created a pyroclastic flow. Its temperature can reach an insane 1,300 degrees Fahrenheit. You see how this flow gets formed from rock fragments and surges down the flank of the volcano at a speed of several hundred miles per hour. Ash is raining down on Earth like grayish, powdery snow. Volcanic ash consists of tiny particles of pulverized rock, volcanic glass, and minerals. When the ash gets mixed with the water from mountain streams and rivers, raging mud flows appear. Despite how scary it all looks, you get closer. Good thing you're wearing a protective suit that can withstand any temperature. The nearer you get, the more fumaroles you spot. These are holes and cracks at the base of the volcano and in its slopes. They emit huge clouds of steam and volcanic gases, carbon dioxide and sulfur dioxide. Some of the cracks are so large, you can probably squeeze through and sneak a peek inside the volcano. But you have a different destination, the crater. On your way there, you spot a strange conical structure on the side of the volcano. It looks like a horn growing on the main cone. It must be a secondary cone, also known as a parasitic cone. Such cones form around secondary vents that reach the surface of large volcanoes. In this case, an eruption can occur not only through the main vent at the top of the volcano, but also through these additional vents. In any case, that's not where you're heading. Soon, you reach the crater. It's a massive circular basin. When you go to its edge and look inside, you see it's also very deep. The lava vent, which is where you need to go, is at the bottom of the crater. But even before jumping into the vent, you spot some strange tubes hiding under the lava flow. Those are lava tubes, natural passages through which fresh liquid lava travels beneath the surface of the lava flow. You decide to make a detour and follow one of the tunnels. It's the main lava tube. You also spot several smaller tubes. They supply lava to one or more lava flows. If the volcano wasn't erupting at the moment, the lava would drain downslope from this tube system. The passages would have lava marks on the walls, a flat floor, and lava stalactites hanging from the ceiling. But even now, there's some empty space above the flowing lava. That's because it has eroded downward, making the tube deeper. But right now, you need to get back. You take the next turn and get back to the crater. You wait till the volcano spews another portion of boiling lava and dive into the volcano's throat. It's the entrance of the volcano. Lava and volcanic ash get ejected from here. The volcano's throat is wide, and you easily travel deeper down. The lava around you glows bright red and orange. That's because when it first bursts to the surface, its temperature can reach 2,200 degrees Fahrenheit. That's hot enough to melt iron. You move down the volcano's main vent. It's a weak point in our planet's crust. There, scorching hot magma manages to escape from its chamber and reach the surface. While going deeper and deeper into the vent, you notice sills. Sometimes, lava intrudes between the crack in the crust, pools there, and crystallizes. This creates deposits of ash and solidified lava. That's what sills are. Pretty soon, you reach a magma chamber. It's a large pool of molten rock. The one you're in at the moment is quite shallow. That's because it's not the main one. After traveling several more miles down through the vent, you get to another huge magma chamber. It supplies the small one beneath the base of the volcano. The main magma chamber lies in Earth's crust, which stretches from 3 to 44 miles deep. The molten rock there remains under extreme pressure, and the temperatures inside are incredibly high. With time, the rock surrounding the magma chamber starts to break and fracture. This creates outlets for the magma, and since it's made of a much less dense material than the surrounding rock, the magma begins to seep through the cracks to the surface. From the main chamber, it rises to the upper one. Then it makes its way to the surface in a powerful eruption. You explore the magma chamber and then decide to go even deeper than that, to the place from where all that molten rock gets into the magma chamber. You're moving through the crust. The volcano is located on land. That's why your trip takes longer than it would if you were traveling through the oceanic crust. It's only 3 to 6 miles wide. But the continental crust is much thicker. It can be 28 miles thick in some places. As you're going through the crust, you can't but notice its light color. That's because it consists mostly of granite. If you were going through the oceanic crust, the material surrounding you would be dark or nearly black because it has a different composition. The deeper you go, the hotter it becomes. Sure, the temperature here isn't as high as in the magma chamber, but still, at the boundary with the mantle, your thermometer shows 750 degrees Fahrenheit. At a depth of about 20 miles, you reach the boundary between the crust and the Earth's upper mantle. There, the pressure reaches a mind-boggling 10,000 atmospheres. That's where magma comes from. You could finish your journey and get back to the surface, but your curiosity gets the better of you. You decide to go deeper, all the way to the center of the Earth. The next layer on your way is the mantle. It makes up 2/3 of the Earth's mass and 84% of our planet's volume. It's 1,800 miles thick. The rock closer to the inner part of the mantle is semi-solid, like caramel candy. The upper part of the mantle, as well as the crust, is broken into massive pieces. They look like a colossal jigsaw puzzle. Those are tectonic plates. They drift at a speed of 1 to 2 inches per year. You're moving through the upper mantle and feel the temperatures rising up to 1,600 degrees Fahrenheit. Near the boundary with the core, the temperature is already as high as 7,000 degrees Fahrenheit. The pressure in the lower mantle reaches 240,000 atmospheres. You'd feel the same pressure if 3,300 elephants made a tower on your head. At a depth of about 1,800 miles, you see the boundary between the mantle and the outer core. The insides of the planet around you are heated up to 9,000 degrees Fahrenheit. Such temperature is high enough to keep the outer core liquid. The pressure there is almost 2 million atmospheres, but it's not enough to make the iron that the core is made of solid again. The outer core is 1,500 miles thick. It churns in massive turbulent currents and generates a magnetic field. In the outer core, Earth's magnetic field is 50 times more powerful than at the surface. You are now more than 3,000 miles underground, and you've reached the inner core. It's a solid metal sphere, around 1,500 miles across. The inner core is immensely dense and spins faster than the rest of the planet. The temperature there is as high as on the surface of the sun, 9,800 degrees Fahrenheit. And the pressure inside the inner core is 3 million times greater than on the surface. It took about 500 million years for the inner core to form, which means it's younger than some parts of the crust.
Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, The mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has two parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lunch, lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa and Eurasia will be flipped on its side. So people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novopangea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novopangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. These ominous rumbling sounds, the ground shaking under your feet. Wait a minute, that's my tummy. Or it might be Washington State's Mount Adams waking up. It's the largest volcano in the state by both area and volume, and it's recently started to show signs of life after staying silent for thousands of years. Scientists have noticed an alarming uptick in seismic activity around the mountain. And since the last eruption here happened between 3,800 and 7,600 years ago, humanity was still in the Stone Age at that time. This sudden chattiness has scientists, let's say, curious. The U.S. Geological Survey has hurriedly installed temporary seismic stations around Mount Adams to keep an eye on the situation. At the same time, they reassure the public there's no need to panic. Mount Adams doesn't reach the height of the better-known Mount Rainier, and still it covers a massive area, making it Washington's largest active volcano. Interestingly, records show that before September of this year, Mount Adams had experienced an average of just one small earthquake every 2 to 3 years since 1982. And then, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in just 1 month, September. These quakes were all rather tiny, with magnitudes ranging between 0.9 and 2 on the Richter scale. It means they were so weak you wouldn't feel them at the surface. Plus, satellite imagery confirmed there was no ground deformation in the area. Now, at the moment, the USGS keeps Mount Adams alert level at green or normal, so we shouldn't worry about the ground opening and swallowing towns and cities. But the most recent seismic blips have encouraged the agency to install additional equipment for more precise monitoring. Such an expanded network will help scientists notice even the smallest earthquakes, which will help them understand what's happening under Mount Adams. This extra equipment might also shed light on whether this recent activity is a signal of future eruptions or just a random anomaly. If Mount Adams eventually erupted, it would likely produce slow-moving lava flows rather than explosive eruptions like Mount St. Helens. After all, past eruptions have only led to lava flows that travel just a few miles from the volcano, so that's not what we'd need to worry about. A much more dangerous thing would be lahars. These are mud flows that can happen when volcanic ash, rock, and melted ice mix during eruptions. Lahars have occurred near Mount Adams without even eruptions. Rock, weakened by hydrothermal processes at the volcano's summit, suddenly broke loose, creating fast-moving, destructive mud flows. Exactly for this reason, the USGS categorizes Mount Adams as a high-threat volcano. While it doesn't erupt frequently, it still poses serious risks to nearby settlements. Another volcano we should carefully watch is Katla in Iceland. It's one of the country's most powerful and dangerous volcanoes. It last erupted over a century ago in 1918, but if it erupts again, it could be 10 times as powerful as another Icelandic volcano whose name I can't pronounce. See? That one erupted in 2010, completely disrupting air travel all over Europe. An eruption of Katla could release large amounts of sulfur dioxide, which could form sulfate aerosols in the atmosphere. Such aerosols reflect sunlight, which could even cause temporary global cooling. This phenomenon often followed catastrophic volcanic eruptions in the past. Although eruptions are common in Iceland, Katla's ash cloud would likely shoot higher into the sky and cover larger areas of Europe than that other one did. It would ground flights and negatively affect economies. If Katla erupted, it would also harm agriculture, water supplies, and air quality. In 2014, scientists noted that a large eruption could even cause a tsunami that might travel along Iceland's south coast and out to sea. But the potential impact of such a tsunami is still unclear. Katla tends to erupt on a regular schedule every 40 to 80 years, which means that another eruption is statistically very likely soon. That's why Katla remains under close scientific observation. The Canary Islands' Cumbre Vieja erupted recently in 2021, reminding people of its destructive potential. The lava flow from this eruption was devastating. It covered whole neighborhoods and flowed into the ocean, destroying more than 3,000 homes. Thousands of people had to be evacuated. But the craziest thing? Even though the damage was significant, scientists believe it could have been far worse. A massive eruption of Cumbre Vieja could have caused the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could have potentially created waves hundreds or even thousands of feet high. They could have flooded coastlines around the Atlantic Basin, including parts of the US and Europe. Luckily, recent studies claim that a collapse of that scale is unlikely. But even though the chance of a mega tsunami is low, scientists still think it's wise to prepare for possible eruptions because there's a chance of extensive damage. The lava flows that occur at this volcano tend to be extensive and dangerous to both human life and the infrastructure on the island. If you decide to travel to Ecuador, you should be wary of Cotopaxi, one of the most active volcanoes in this country. It's been rumbling with minor eruptions since 2022. While these eruptions have been relatively small, Cotopaxi has a great potential for a major eruption, and it has scientists on high alert. If Cotopaxi erupted on a large scale, it could produce a massive ash cloud over 12 miles high, threatening the lives of around 200,000 people in the neighboring area. A serious danger is Cotopaxi's snow-capped summit. It would melt super rapidly in a major eruption. It could lead to destructive floods and landslides that would flow down the mountain and potentially reach populated areas. This combination of volcanic activity and glacial floods makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, or it could be years or even decades away. But monitoring efforts are in place to catch any warning signs. The next volcano we should watch out for is already infamous, Mount Vesuvius. Its catastrophic eruption in 79 CE destroyed the Roman cities of Pompeii and Herculaneum. Its last eruption occurred in 1944, but Vesuvius remains highly active and poses a great risk to nearby Naples, one of Italy's largest cities. A large eruption would threaten over 3 million people. Many of them live in the vicinity or even directly on the slopes of the volcano. If Vesuvius erupted, it would be an explosive event, with ash, rocks, and volcanic gas ejected at extremely high speeds. And even though such a destructive event isn't expected for a few hundred years, Vesuvius remains one of the world's most closely watched volcanoes. After all, it has a real potential to cause catastrophic damage in a densely populated area. Then we have Popocatépetl, often called El Popo. It's one of North America's tallest active volcanoes, which lies about 40 miles from Mexico City. Exactly this proximity to a metropolitan area with a population of 22 million people makes Popocatépetl especially hazardous. A large eruption could send a massive ash cloud over Mexico City, causing widespread disruptions. Ash could clog the city's drainage systems, contaminate water supplies, and even cause power outages by short-circuiting electrical systems. Plus, lahars could rush down the volcano, reaching nearby towns. Popocatépetl has been showing near-constant seismic activity since the early 2000s, and smaller eruptions are pretty common here. In early 2024, there were 13 recorded minor eruptions, which alarmed nearby towns. At the same time, volcanologists consider such eruptions normal for Popocatépetl. While talking about super dangerous volcanoes, we can't skip Yellowstone National Park. It houses one of the world's largest supervolcanoes. Its last massive eruption occurred about 640,000 years ago. But if this monster were to erupt today, the impact would be much more devastating for the entire planet. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would be most affected, likely experiencing disastrous pyroclastic flows. These flows, which are made of a dangerous mix of lava, ash, and gases, can obliterate everything in their path. Large parts of the country would also be blanketed in volcanic ash, over 3 feet in some areas. On a global scale, an eruption at Yellowstone would send tons of ash and gases into the stratosphere, potentially blocking sunlight and causing global temperatures to drop for a few years. This would disrupt agriculture, collapse transportation systems, and create food shortages on a massive scale. Still, even though there's a popular myth that Yellowstone is overdue for an eruption, geologists clarify that this isn't true. Volcanoes don't follow precise timetables, and the activity at Yellowstone doesn't indicate an imminent eruption. So yeah, that's good news.
It's the 15th of January, 2022, 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hunga Tonga Hunga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. 2 seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption. The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, this discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, the sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum. And that's at its highest pitch, all because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors. Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or a pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, The sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which, in turn, protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, We're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot. The island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the Sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds. An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered, so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
If you live in a hot spot for earthquakes, like I do, you may have had these familiar shaking feelings. The ground trembling underneath you, pictures rattling on the walls, your neighbor's dog yapping across the yard. An earthquake is basically tectonic plates moving and grinding against each other. Rub your hands together really fast right now. Things heating up? That's energy. When these plates' energy get released, you and your neighbor's dog feel it on land. Yes, we're all surfing on giant pieces of land floating on hot liquid rock. You're surfing right now while watching this video. Sometimes one slides under another, like reaching in between the couch cushions for that remote that slipped down there. If you're wearing long sleeves, they get rolled up on your arm like a snake shedding its skin. When plate tectonics do this, mountains form. But let's zoom out from your bedroom. Even further. Keep going. There. Earth, the third planet from the Sun, covered in mountains, canyons, and those familiar continents with oceans stretching between and all around them. But our planet used to have just one single supercontinent, Pangaea, where all the land masses were hugging each other and enjoying the sweet life surrounded by one massive superocean. Africa and Australia were neighbors. The Americas and Asia popped up for a howdy neighbor. But fast forward about 300 million years, and here we are. And there you are, hanging 10 on molten rock as the ground beneath you forms mountains, ridges, volcanoes, and earthquakes. Sounds hardcore, but you don't feel like you're moving, do you? You also don't feel like your body is going highway speeds when you ride in a car. That's physics, and it's a funny thing. Right now, the plate under you is only moving a couple of inches a year, up to 4 when things get super speedy. Per day, that comes to half the width of a strand of hair. So let's speed things up a bit, say 300 feet a day. And me too.
You're sitting in your room enjoying a delicious cup of hot cocoa, scrolling the feed and watching some videos. As you set the mug on the nightstand, you begin to feel dizzy, like the room is spinning. You check your drink and see the liquid inside is swaying like crazy. Uh-oh, now you're swaying. You manage to get up but can't keep your balance. Everything topples over like a tornado in the room. You duck underneath your bed and cover your head. There's a power outage, and now you can't see anything.
There are 2 things to keep in mind when it comes to earthquakes: magnitude and intensity. Magnitude is the size of the quake. It's just one constant number. Intensity is how much shaking it causes. That number can be different depending on where you're measuring from. The most powerful earthquake ever was in Chile in 1960. Its magnitude measured 9.5 on the Richter scale. Above 7 is considered severe. The quake caused tsunamis all the way to Japan, Hawaii, the Philippines, and even New Zealand. The damage cost millions of dollars in repairs.
In the dark, you can still feel the ground shaking below you. And since the crust cut across 300 feet today, the ground rips open. The landscape where you used to bike around is now sprouting deep earth rocks and minerals. The buildings all around begin to collapse, but luckily, you manage to sneak off and escape into an open space. There isn't any service on your phone either. The cell towers toppled over during the quake, but the ground is still shaking. And with the plates moving so fast, the Earth's interior begins to show its true colors. And that color is red, red for red hot. You can see the mantle at this point. The Earth, like an onion, is revealing its layers. With magma flowing right in front of you, you'd think you're in a disaster movie. Suddenly, you get a whiff of salty sea air, and now you're standing on the beach. But wait a minute, you don't live by the coast. If an earthquake's strength is measured by magnitude and intensity, this one's a doozy. It probably originated out in the ocean and stretched all the way inland where you are. It caused a tidal wave so big, the coast just came to your landlocked town. Waves of ocean water are gathering near the edges of the city. Farms and rivers are all gone with a single tidal wave. The land that was good for agriculture is no more. And as the ground below you keeps on cutting, it lets in some ocean water between the gaps. It collides with the magma that's rising. Steam shoots up from the ground, and the Earth looks like a giant tea kettle. With the power out and no cell signals, there's no way of communicating with anyone. And that's just the thing with earthquakes. They can show up with hardly any warning.
Unlike earthquakes, tornadoes, and typhoons, with those, we can predict their path and intensity. We can prepare. Even volcanic eruptions give people enough time to evacuate and reach safe ground. But earthquakes are just in a league of their own.
And with all the buildings collapsing around you, you'd be seeing a smokescreen of dust and debris. The air would be unbreathable. Better grab a gas mask. Off in the distance are the mountains you've always enjoyed. You trekked along the trails every other weekend and had some fantastic camping trips along the river. But the earthquake drags across the center of the mountain and creates enough pressure to cut it. Trees start falling over. The mountain becomes a pile of rock and dust. It's not over yet. The shaking ground makes large pieces of land and rock slide down and head towards the town. Some landslides are so massive, they're enough to wipe out entire villages in remote areas. Many come after heavy rain, others come completely unexpected. With the ground opening beneath you, many of the objects on land get swallowed into the pit. Cars, trees, buildings, statues, you name it. You're able to find safe ground, but you can't really know if it's all that safe. All this is happening in your town and places across the globe. But it's about to get even more global.
Plate tectonics are crucial for life on Earth. One of their main duties in a thankless job was maintaining the planet's comfortable, livable temperature. Without landmasses floating around on a layer of liquid rock, there'd be no life on the liveliest planet we know so far. A couple of billion years ago, Earth was just a little ice ball. This was because the sun, much younger back then, was colder than it is today. You'd think the oceans would be frozen and good enough to skate from the Atlantic to the Pacific, but they weren't. And it's all because scientists believe the shifting plates underneath kept the oceans warm and cozy. They did that by creating underwater volcanoes. Besides lava and many gases, they spewed carbon dioxide into the atmosphere, which trapped the heat on Earth. As the sun gradually got hotter, rainfall was able to drag the carbon dioxide back to the ground and into the mantle. And this cycle was able to help the Earth maintain its temperature to host us. Gee, how thoughtful. Earth is so unique because of these plate tectonics. No other planet in the solar system can brag of the same, except for Jupiter's frozen moon Europa. It's shown evidence of moving plate tectonics within the core. And even though Venus and Mars have hot interiors, there hasn't been any sign of such activity.
As the ground continues to cut across the land, everything in sight has now descended underground. If the plates were to move 300 feet a day for a year, the entire planet's landscape would go through a total makeover. A bad one. Life as we know would cease to exist, except for maybe microscopic bacteria and a few insects that can survive such harsh conditions. The polar ice caps wouldn't hold any more ice, and volcanoes would continuously be erupting. The planet would just end up looking like a hot fireball of destruction, and maybe even burn up entirely.
Luckily, this is purely a hypothetical thought experiment. So, sit back, relax, and don't worry about the ground moving under your feet. It's taking its sweet time at a safe pace.
Woohoo!
You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive. And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. It's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity times 2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes, making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6, otherwise bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now. The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. Imagine you're stepping on board a once-in-a-lifetime Arctic expedition that departs to the east coast of Cape Bathurst in Canada's Northwest Territories. It's said that the location you're headed is unmatched on planet Earth. The final destination is an unbelievable location known as Smoking Hills. These red-striped rocks have been burning there continuously for centuries. It has minerals there that are only found outside our planet, on Mars. Some scientists even believe that the site can be an important case study for discovering life on the Red Planet. On board the small cruiser ship, you head out to the deck and spot an unusual scene on the horizon. You see clouds of smoke forming close to a seaside hill. It's as if a party of hundreds of people did campfires all at the same time. But this smoke is not man-made, your guide tells you. Naturally, most people guess it's a volcano. Some people on the deck even guessed that an eruption might happen anytime soon by the looks of it. Your guide laughs, explaining that this is far from the case. Volcanoes are usually found on the edge of tectonic plates. It's a rupture on the crust of the Earth that allows hot lava and gases to escape to the surface. In the Smoking Hills, the story is different. The constant smoke is caused by a natural phenomenon. But you'll learn all about it over the next few days. As strange as it may sound, these rocks didn't begin burning yesterday. According to experts, the ground on Smoking Hills has been releasing clouds of smoke for at least a couple hundred years, non-stop. You heard it right, but experts are still unsure how long they've been burning. It could be thousands of years. Now, before you leave the ship, some instructions are in order. The expedition leader explains you're going to enter a high-risk place. So, we replace your regular hiking boots and clothes with a special suit and gas mask before stepping on site. The clouds of smoke you are now watching from a safe distance are composed of sulfuric acid. This chemical is highly toxic. You need to be careful while breathing its air. So remember to keep those masks on. Oh, and as tempting as it may look, don't touch anything with your bare hands. Legend says that the first crew to explore the Smoking Hills found it by mistake. And imagine, these people had none of the gear you're going to use. First written records on the Smoking Hills date back to the 1800s. Irish explorer Captain Robert McClure led an expedition to find the lost explorer Sir John Franklin and had disappeared for over 5 years. The crew took a wrong left along the way and stumbled upon these burning rocks. They also thought it was an active volcano, much like you did, but they discovered how wrong they were when they stepped on site. McClure got curious and took a sample rock back to the boat, and the story says it burnt a hole through his mahogany desk. Remember this when you feel like taking a souvenir home with you. It might not burn a hole on your desk, but it sure will fly through your pocket or any container you try to use to take it. Now it's day 2, and you're ready to explore the location. The expedition's crew is divided into smaller boats. On your way to the shore, you notice a group of animals. They are far from the smoke, and it looks like they have themselves a mealtime. The smoking hills are located in the Arctic tundra, and there are rich fauna and flora nearby. Slowly, you're approaching the shore. Now you see the cliffs are made of red striped rocks that look like they've been hand-painted by someone. There's another place on Earth with similar hills, and it is located in Peru, all the way to South America. The so-called Rainbow Mountain or Seven-Colored Mountain is a mesmerizing natural phenomenon. They are formed by the sediment of different materials. While the smoking hills are mainly red, over in Peru, these mountains have stripes of lavender, gold, red, and even turquoise. When you finally leave the boat on the foot of the smoking hills, you begin your hike up. Stepping is difficult with your special boots. The soles are made specially to support high-degree temperatures, but it sure is hard to keep your balance. Before you know it, you're as close to the burning rocks as you can get. Your first impression is to get out of there as fast as possible. Conditions for human life are harsh over there. It's inhospitable, and everything about the place says you shouldn't stay for long. But you are also beyond curious. You might ask yourself how these rocks keep burning for so long. The science behind it is not too complicated. The rocks you're looking at are called shales. They are a type of sedimentary rock formed by clay minerals. Your guide explains that the secret to the smoke lies on the ground. The soil is formed by sulfur and coal. When they get in contact with oxygen, they spontaneously ignite, releasing the smoke you're now seeing. The few ponds in the region have very acidic water. Scientists say that this world region is the only one to show a negative pH. It means this water is naturally corrosive, so you don't dare drink it. Make sure to bring your own water bottle when leaving the ship. You spend a few hours there, but it seems like a whole day. The suits are heavy, and breathing through a gas mask is not your idea of comfort. At the end of the day, you head back to the ship, enjoying a beautiful Arctic sunset on the way. On the morning of your third day, you're in for a nice surprise. You're not heading out again. Instead, you're going to take a trip to outer space. Metaphorically, of course. Your guide talks about the connection between the smoking hills and Mars. Looking for life on Mars has been a journey all on its own, but recently, scientists discovered the exciting presence of jarosite on the smoking hills. And guess what? Jarosite is an abundant mineral on Mars. Experts think that this may indicate that Mars did have running water at some point in the past, since jarosite needs groundwater to form. This huge discovery may take science many steps closer to a breakthrough. Has life really existed on other planets in the solar system? Mars has been on the map for scientific research for being the most likely planet to have developed life. The atmospheric temperature now is unbearable for above-ground life, but it was similar to Earth's at some point. The most important proof needed is to find the evidence of running water. Right now, as we speak, the Curiosity rover is out there looking for any piece of information that can hint at the existence of life on Mars, past or present. Just out of curiosity. Curiosity, the rover I mean, has been exploring the surface of Mars for over 3,566 days so far. If you do the math, it makes for 9 years and 279 days. And in case you're wondering, why are we so eager to find life on other planets? According to NASA, the research for life on other planets can help us explain a lot about our own history, where we came from, and maybe even where we're headed. And who could have guessed that scientists could begin to find answers for that in the Arctic tundra? That's exciting, right? Now, it's day 4 aboard the ship, and the expedition is coming to an end. Time to head back to mainland Canada. You just visited one of the world's most inhospitable places with a lot of impressions. Now, it's time to tell us what you thought about the journey and what you learned along the way. Write it all down in the comments below.
In the high altitudes of northern China, there is one mountain that remains frozen all year round. It's a naturally occurring spot of cold earth. A thick layer of permafrost lies underneath the mountain's top layer of soil, freezing everything above it. The climate-defying pocket of frozen land covers over 26 feet of a mountain slope in Pingchuyen County, a place famous for its scorching hot summers, reaching highs of 90 degrees Fahrenheit. This frozen spot of land manages to survive the blazing temperatures due to the coarse blocky layer of soil covering the permafrost. This coarse soil prevents the hot climate from reaching and melting the permafrost, allowing the ground to stay frozen all year round. Argentina may be famous for its beautiful beaches and hot sun, but in southern Argentina, you can find Perito Moreno Glacier. This stunning blue glacier covers over 100 square miles and is constantly growing. When visiting this natural wonder, you might notice an archway of ice forming off the side of the glacier, reaching out to the nearby land. Suddenly, the archway ruptures and the ice collapses into the water below. This is completely natural. The glacier goes through a process of forming these arches until they collapse. It'll form another one in no time. On California's Glass Beach, there's no sand and only colorful gemstone-like pebbles called sea glass. Surprisingly, these beautiful pebbles are the result of garbage. For decades, the beach was used as a massive dumping ground for locals to abandon their glass, appliances, and even cars on the beachfront. The state eventually prohibited anyone from disposing of their garbage on the beach. Over the years, the waves broke down all the remaining junk and turned it into brightly colored pebbles that attract tourists from all over. The highest waterfall in the world, Angel Falls, can be found in southern Venezuela. The water there travels along one of the biggest tabletop mountains in Venezuela and plummets 2,500 feet down into the jungle below. That's 3 times taller than the Eiffel Tower. The water falls from so high that most of it evaporates into mist before even reaching the ground. Visitors can feel the mist settling on their skin from over half a mile away. In Scotland, hidden away from the main roads and tucked deep within the woodlands, is Fiddick Glen. This area looks like something out of an ancient fairy tale, with looming glass moss-covered rock formations and crimson red waters. The water's red color is due to the red sandstone lying beneath the shallow river. To get to this stunning natural beauty, you have to embark on a dangerous hike down steep, muddy hills, clambering onto trees to stop you from falling. But when you reach the bottom, it'll all have been worth it to watch the sunlight shine off the ruby waters and see the towering rocks of this enchanting world. With bubblegum pink water and a surrounding circle of emerald green forests, it's hard to believe that Lake Hillier is a real place. Located in Western Australia, no one can truly explain why the lake has pink color. However, scientists have theorized that the high quantities of salt in the lake have attracted a salt-loving pink bacteria called halobacteria, responsible for the lake's trademark shade. In a small peninsula in South America, there is one of the most beautiful natural wonders in the world, the Marble Caves. These look like any other caves from the outside. Inside these caves, the walls consist of smooth, swirling blue marble formations. Over thousands of years, water has eroded the marble deposits within these caves, forming this unique cave system. So while deep blue color seems like it's part of the marble, it's the reflection of the water that causes these blue shades along the cave walls. Azerbaijan's mud volcanoes are exactly what they sound like. Over 300 of these natural phenomena are located in Azerbaijan, more than anywhere else in the world. There have been over 200 eruptions since records began. Mud volcanoes are landforms caused by the eruption of mud, water, and gases. Pockets of gas form underground and force their way to the surface, eventually erupting and splattering mud everywhere. These volcanoes can be pretty dangerous. In 2006, a mud volcano erupted in Indonesia and coated an entire nearby village in thick mud. Pamukkale is a marvelous hillside of tiered thermal pools. The name of the Turkish city translates to Cotton Castle. The pools are made of travertine, a type of limestone that gives the hillside its stunning white color. In addition, the stone has geothermal properties, making the pools hot springs. There are 17 pools in total, and all are open to the public 7 days a week. The temperatures range from 95 degrees Fahrenheit all the way to 212 degrees Fahrenheit. They are essentially nature's version of a hot tub. Legend has it that the Giant's Causeway in Northern Ireland was formed when a great Irish giant was challenged to battle a Scottish giant. The causeway was built across the sea so the two giants could meet. When the Irish giant defeated his foe, the Scottish giant ran home and destroyed the causeway behind him. All that remains are the beginnings of the causeway at the water's edge. The stunning rock formation of interlocking columns was the result of an ancient volcanic eruption. The columns are a hexagonal shape and form a natural staircase from the Irish Sea to a foot of a cliff. The tallest columns are 39 feet high. The Giant's Causeway is the most popular tourist destination in Northern Ireland, receiving almost 1 million visitors in 2019. Deep within the Nika mines in Mexico, you can find the Cave of Crystals. The cave is full of massive shards of bright selenite crystals. The largest is 37 feet tall. These are some of the largest natural crystals in the world. It's thought that the water that previously filled the cave was incredibly rich in minerals, allowing the crystals to grow to their full potential. Unfortunately, tourists cannot visit the Cave of Crystals due to its scorching temperature and humid conditions. Even scientists are required to have a special permit to enter the cave. The River of Five Colors is located in the Colombian province of Meta. Known locally as the Rainbow River, the waters are famous for their striking colors. The river is variously colored yellow, green, blue, black, and most prominently red from summer till winter. Due to a lack of nutrients, the river's water is naturally clear, so it's easy to see diverse and colorful plant life on the riverbed. It's these vibrant plants that give the waters its many colors. In New Zealand, you can take a boat ride through the beautiful Waitomo Caves. The walls of the caves glow luminescent, like bright stars against the night sky. But these glowing lights aren't stars, they're worms. Luminescent glowworms live in the walls of the cave, giving the cave its trademark glow. The particular species of glowworms cannot be found anywhere else in the world. For thousands of years, the fairy chimneys have stood tall in Cappadocia, Turkey. These unusual rock formations are tall, thin spires of rock that were initially formed by lava. The tallest chimney is 130 feet high. Humans have hollowed out the insides of these rocks for hundreds of years to create homes for themselves. Today you can visit one of the many hotels that currently exist inside the fairy chimneys. Wave Rock is a popular spot for a photo shoot in Western Australia. The giant rock is 46 feet tall and shaped like a breaking ocean wave. Millions of years of strong winds and hard rainfall eroded the rock into the wave-like shape it has today. The rock has a stunning mix of red and gray colors caused by minerals washed down the rock. The site of the Wave Rock has become a famous camping ground due to its proximity to beautiful lakes and a variety of wildlife. The Zhanyi National Geopark in China has previously been voted one of the most beautiful landscapes in the world. The park is famous for its colorful rock formations, popularly known as the Rainbow Mountains. Layers of minerals and different colored sandstone were slowly pushed together across 24 million years to create the stunning landscape.